Alright guys, pre-calculus 1.2, just a warning, this section has a ton of information in it. Okay, this is going to be a big review of all types of functions that were kind of covered in Algebra 2. We will do linear functions, quadratic functions, radical square root functions, rational functions. Okay, we're going to talk about all these different properties, domains, ranges, asymptotes, minimums and maximums, also known as extreme values or extrema, the end behavior, and also where they're increasing and decreasing. Okay, so just kind of buckle up. We got a lot going on. Let's get into it. Let's review what some of this stuff even means. So when you see the term domain, okay, some people always say x values, and that's true, but technically we need to be saying it is all possible x values. Okay, because it's not just the x values that you may see on a graph or if you make a table or something, but it is asking, the domain is saying which values of x are even possible. Is it all real numbers? Is it all, non-negative numbers? Things like that. Okay, so that's domain. The range then has to deal with all y values that are possible. Oops, I guess I forgot to write the letter x up there. Okay, the range is again all possible y values. Okay, meaning which y values does the graph go through? Is there a minimum? Is there a maximum? If not, is the range all real numbers? Okay, we'll get into a bunch of examples. Okay, asymptotes. Only certain types of functions have asymptotes. So let's just define it for now as a line that the graph approaches. Okay, if you remember an asymptote, something you just get closer and closer to, but it never quite gets there. And there's some exceptions. Sometimes you have a vertical asymptote, like in the middle that a graph goes through, but then there's some on the ends and stuff that may not go through, things like that. We'll see some examples in a little bit. Okay, but more on that soon. Okay, next one we have max and mins, and those are of course the highest or lowest point. And there's a couple different types. There's what's known as an absolute max or min, which is the highest or lowest that the thing ever gets. And then there's a local, or sometimes known as a relative min or max, which is like within a certain section of the graph, it's like the lowest point, but it may go lower somewhere else, that kind of thing. Okay, so we'll talk about that. End behavior. What is the graph doing on the ends? Okay, is it going, like, think of like a parabola where both ends might go up to infinity, or think of like a linear function where one side goes up to infinity, the other goes to negative infinity. There's a bunch of options on that. The way we're going to write that is we're going to say as x goes to infinity, okay, the y values are going to go to, and then we'll fill in the blank. Are the y's going up to infinity? Are they going to negative infinity? Are they going to a different number? That kind of thing. And then on the left side, right, think of a number line on the left side, x is going to negative infinity. The y values will be approaching something as well. So there's always two ends. As x goes to infinity, you say what y does. And then as x goes to negative infinity, you say what y does. Okay, and then increasing and decreasing, we're going to give an interval where the function is either going up or down. And like, for example, think of like just like a basic parabola or something like that. That function would be said to be decreasing all the way to this point, whatever that x value may be, and then from there, as x gets bigger, the y values are increasing. So we're going to find a way to describe where that is happening. Okay, and that's kind of a lead into calculus, and that's what we're doing, right? This is pre-calculus. So let's get into one other little kind of notation, the way we're going to write something just to get used to, and then we'll get into a couple examples. Okay, we are going to use this interval notation, which is probably something we saw in Algebra 2 a little bit. It's just kind of more of like a fancy notation that's used in calculus and beyond quite a bit. So it's something we need to just be familiar with. So I have a couple examples here. of different number lines showing different intervals, and let's show how to write those both as intervals and also in interval notation. Okay, so if you notice, maybe we can just label these. If that's part A, it's the numbers between 2 and 4. The open circles again indicate that 2 and 4 are not included. Okay, so if we were going to write that as an inequality, we could do like the compound inequality. 2 is less than x, which is less than 4. Okay, so that's telling me x can be any number in between 2 and 4, not including 2 and 4. Okay, to write that as an interval, you use the parentheses because the endpoints are not included. Okay, kind of like how the circles are not colored in. We don't have an equal sign under the less than symbols in the inequality. So it looks exactly like an ordered pair. Right? It looks like a point, 2, 4. So you sometimes just have to know, based on the context, are they talking about an ordered pair or are they talking about an interval? So that interval means all numbers between 2 and 4, but not including 2 or 4. Okay, part B now is similar. Let's call this one B, except what's the only difference? Okay, the 4 is colored in. That means the 4 is included. So as an inequality, it would still be 2 must be less than x, but now x can be less than or equal to 4, right? The 4 is included in there. So the closed-in circle tells us that it's included. Now to do that as an interval, the 2 is still not included, so it's a parenthesis. 2 is the minimum, 4 is the maximum, but to include it, we use a bracket instead of a rounded parenthesis. And what I always used to remember doing that was this bracket down here is kind of like the equal sign under there, right? So if there's like a straight, a little straight piece, a straight horizontal section, that's including those values. Okay, if it's just a parenthesis, it does not include those. All right. What about the next one? What if we have something like an open circle at 3, then going to the right? All right, so again, we have an open circle at 3 and all numbers to the right. So that number line is showing all numbers greater than 3, right? So as an inequality, that's just simply x is greater than 3, right? And then to show that as an interval, again, it's minimum first, then maximum. So in this case, 3 is the minimum. 3 is not included, though. So we do a parenthesis to not include 3. Now, there's no ending point, right? So when there's no ending point, we just go to infinity. And you can never equal infinity, so infinities will always have a parenthesis by it as well. Okay, and then we have one more. We have, let's call that D. So this one actually has 2 different intervals, right? So in this case, the first piece is all numbers from 1 to 2, not including either one, right? So 1 is less than x is less than 2. Or there's another group of numbers which are between 2 and 4, not including 2, but it can equal, right? There's a colored in circle at 4. Okay, so we could write it as an or statement like that. And to do that as an interval, we would just have to do the 2 intervals separately. From 1 to 2, not including either one, you can put the word or there. 2 to 4, now we're going to make sure we put the square the square bracket at 4 because 4 is included. Okay, one thing you might see some books use instead of the word or, they use a U, which stands for union, and it's just a fancy way of saying or. Okay, so interval notation is what we're going to be using for when we state the domain and range, when we state where it's increasing and decreasing and that kind of thing. Okay. All right, so let's look at a specific example. Here is a linear function, and let's fill in a bunch of the properties about this thing. Now, a graph's not mandatory, but let's just kind of give ourselves a rough idea. 5x minus 1, we know the y-intercept is down at 1, and then the slope up 5 over 1, so something like this would be our graph. Okay, just to give us an idea of what's going on. Okay, now with linear functions, the cool thing is the domain is going to be all real numbers. Okay, because if you think about it, domain is asking which values of x are possible, right? So the function is 5 times x minus 1. Okay, and you can do 5 times any number you want minus 1. You're going to get a real answer out. So linear functions We're going to have a domain of all real numbers. Okay, we can write the words all reals. We can write the fancy double script R there. Or the new way to write that is an interval notation. All reals really means from negative infinity to positive infinity. Okay, so you can write it any way you want. Now let's think about the range. Is there a minimum or maximum y value? No, right? Looks like it's going up and down. Does it jump over any y values anywhere? No. So same thing, I'm going to do this as negative infinity to positive infinity. All real numbers for the domain as well. Okay, cool thing about linear functions too, and this is one of the reasons they're probably the first ones you do in algebra, they don't really have too many crazy things going on. There are no asymptotes. Okay. Okay, we'll talk about, there's really only a couple types of functions that actually do have asymptotes. Most of these don't. So it's kind of easier to remember which ones do and then know how to find them, which we'll see down the road. But no asymptotes. Does it have a maximum or minimum? Well, if the range is all real numbers, right, the max or minimum is referring to y values. There's not going to be one, right? This thing goes up to infinity on the right side and down to negative infinity on the left side. So definitely no max or mins either. All right, now end behavior. Here's where the graph might be helpful. Okay, let's think about on the right side. Okay, as this graph goes to the right, okay, we say as x goes to infinity, then we're going to state what do the y values do. Okay, well on the right side of this graph, the y values are going up. So they're going to infinity as well. Okay, then on the left side of the graph, as the x values get small, right, as the x values go to negative infinity, what are the y values doing? On the left side, the y values are going down, so the y values are going to negative infinity. Okay, so this thing has the end behavior going opposite directions. You may remember something about the degree of the function. Since this is 5x, it's an odd degree function, right? The exponent is 1. Linear functions are always first degree because they're just mx plus b. There's no exponent on the x. So their end behavior, one end goes up, one end goes down. Okay, and then what about increasing or decreasing? Let's think about it. If you were following this graph, and you got to think about as you read a graph, you always read from left to right, just like you're reading words. What are the y values doing? So as I'm going from left to right, the y values are getting bigger and bigger and bigger and bigger, right? So this thing is increasing from negative infinity to infinity. This is an interval here of x values. Okay, so this thing is always increasing. All right, so let's look at one more example. Let's kind of go through it. This one actually has a couple things that are a little bit different than the last one, so that'll be nice where we can see an example of some of the things with different increasing, decreasing, and stuff like that. I'm going to just graph this really quick on the calculator, okay, because that's going to help me find the min and maximum, and it's also, we'll see, going to help us with the where it's increasing and decreasing. Okay, so let me do that real quick. And I'm going to find the minimum, okay, we go into second trace if you're using the graphing calculator. Let's see, and we can find the minimum. All right, so let's see, the sketch of this thing, I just made a rough sketch here. It appears to have a minimum at 0.2 and 2.8, so it's doing something like, it's definitely a parabola, something like that, and it's not to scale or anything, but the minimum right there, the vertex, right, is again at 0.2 and 2.8 from my calculator. Okay? All right, so let's use that to help us figure out all these properties. All right, so domain. So are there any x values where this thing's undefined? Okay, usually, honestly, that only happens if you have x in the denominator, right? Because x, you can't divide by 0, so that could cause some issues where the thing would be undefined. Or if you have a negative number under a square root, we know those are not real numbers, so So really for now, since quadratics don't have either of those, right, you don't have any variables in the denominator, you don't have any variables under a square root. So just like linear functions, the domain of all these is going to be all real numbers. Okay, I'm going to write it as an interval, but again, feel free to write all reals or this fancy R. Okay, now the range though is a little bit different. Okay, this thing actually has a minimum y value, right? We graphed that. These all quadratics all have vertexes. Okay, so the range, if you think about it, the y value there at the minimum we found was 2.8. This graph only has y values above that, okay, because it opens up. So 2.8 needs to be included, so we're going to use the bracket. Now it does go up to infinity, and we never get to infinity, so I will use the parenthesis on infinity. Okay, that's the range. If we want to, let's fill in the max or min right now. This thing has a minimum. The minimum is the y value, the minimum y value is 2.8. And that occurs where x equals 0.2. Okay, but the actual minimum is talking about the y value. It just happens at a given x value. So if you guys give me the ordered pair, I mean, I'll probably take that, but technically the minimum, right? The minimum is the y value, 2.8, and it just happens to occur at that certain x value. Okay, asymptotes. So parabolas, right, quadratics do not have asymptotes. The one that's going to have asymptotes is going to be the rational functions, and then down the road trig functions, but we won't do that till later in the year. Some of those do when you graph tangents and the other ones. But linears, quadratics, even square root functions don't have asymptotes, so we'll just say none. All right, now end behavior though. Okay, let's think about this. So we got two ends, right? We always have two ends that we need to state. Something's happening as x goes to infinity. We're going to say something. And then something separate happens as x goes to negative infinity. Okay, something on the right end, something about the left end. So the right end, what's happening on the right side of this graph? What are the y values doing? They are going up. So they are going to positive infinity. And on the left side of this graph, right, on the left side, think about as the x values go negative, right, that means left. The y values are going positive still, positive infinity. Okay, so this graph, both ends go the same way, and if you remember, that's what happens on even degree functions. Both ends go up or both ends go down. We talked about that in Algebra 2. Okay, but you can use the graph of this to help. Okay, so there's that. Now here's the kind of new part, increasing and decreasing, okay? Where is the function increasing? Where is it decreasing? That kind of thing. So, okay, if we start out, I always read a function from left to right, okay? Let me just draw another one here so we can think about it. So as this graph begins, right, it's kind of doing from the left to the right, it's doing this. Then it gets to the minimum there, right? So at that point, as we go to the right, the y values are getting smaller. So this thing is actually decreasing, and we're going to state now what interval of x values is it decreasing. Okay, it's decreasing all the way from, these are x values now, from negative infinity all the way until it gets to that vertex. And what was the x value at the vertex? 0.2. Okay. Then the graph, as we keep going, starts to now be an increasing function, right? It switches, right? That's the cool thing about parabolas. They change. It's now increasing. And we're going to say which interval is it increasing over? Again, x values here. From 0.2, when x is 0.2, it's going to increase for the rest of the x values all the way through positive infinity. Okay, notice now 0.2 itself is not included in either interval there, right? At 0.2, this thing's not increasing or decreasing. It's called a turning point. Okay, big thing in calculus when you guys get there. A turning point, it changes from a decreasing function to an increasing function. That is a turning point. Okay, so a little bit tricky on that. The new thing again is that when you talk about increasing and decreasing, you are giving an interval of x values. So these are intervals of x's where it's increasing or decreasing. Okay, and that will kind of get us through this first part. In the second portion, we will get into other types of functions.